Good evening everyone. My name's Libby Cotchett and I welcome everyone here tonight to the webinar brought to you by Murrindindi Library Service. Thank you for attending. We've had a huge interest in this event with over 500 people registered. David's presentation will be about 45 minutes long and there'll be an opportunity for questions at the end, probably about 15 minutes. Questions can be submitted through the Menti link that you received in your email, and David will get through as many questions as he can in that time. So it is my great pleasure to introduce internationally recognised ANU ecologist, conservation biologist and author, Professor David Lindenmayer. David is a scientist and an academic, an expert in landscape ecology, conservation and biodiversity. This session, this evening, will summarise 37 years of study and research into ecology and management of the wet forests of the Yarra Valley. David, we welcome you and it's over to you now. Thank you.
Thank you, Libby. Now, I think the screen is going across to share screen, is that right? Okay, so I wanted to talk about some of the key points that have arisen from the last 37 years of work in the Yarra Valley and the Central Highlands of Victoria. But I started this talk not with a photograph from Victoria, but from outside of my house in Canberra in 2003. And this is a huge pyrocumulus storm that was building the afternoon that Canberra burned in 2003. So fire has been a pretty key part of my life for well over 3.5 decades. So to give you some background to this talk, we've been working in the Central Highlands and elsewhere since 1983. So July will be 37 years since I first started in the region that you're in. And we've had major fires in 1983, and then in Canberra in 2003, as we saw in the previous slide, then again in 2009 in the Central Highlands area. And then we've worked in fires on the coast of New South Wales in 2017, and most recently 2019, 2020. And our studies of fire have included work in forests, but also in plantations and in temperate woodlands and coastal heath. And so there's quite a range of different aspects to fire science from those different studies. And fire's been a really key part of all of our work, but particularly in a range of books that we've completed and quite a number of scientific publications. Excuse me. So just about everything that we're going to talk about in the next 45 minutes is actually underpinned by peer-reviewed scientific research. And that's really important because it's quite a rigorous process to make sure that the work that's done is robust. And we take special steps at many levels to make sure that that's what happens. So we do quite a large number of large-scale studies across southeastern Australia. And the arrow points to the Central Highlands area where we're going to focus this talk. But we could talk about fire in the context of temperate woodlands, for example, in the yellow and orange areas, or Jervis Bay on the south coast of New South Wales, where you have some specific fire experiments that are running. But this talk really focuses on the Central Highlands region. And it's an area that we started working in July 1983. And many parts of the Central Highlands are still truly spectacular areas. This is actually a photograph taken of me in one of our long-term sites deep within the O'Shanassy water catchment. Truly spectacular places, as many people would realise. So in that 37 years, we've produced a lot of scientific articles, produced a lot of books, and also made a very large number of scientific measurements of different aspects of the forest and the forest fauna. And that really is important in terms of underpinning this story with extensive science and scientific research. So in this talk, I wanted to do several things. The first one, I wanted to talk about a little bit of background to the current fire season and produce some of the definitions that I think often get confused in the media. Then I wanted to talk a little bit about the link between climate and fire, and then move to hazard reduction, burning and house loss, and then some themes around forests and fire, and then conclude with some things that I think we can do to tackle some of the challenges that are coming with these increasingly frequent and severe and extensive fires. So let's move to the recent fires that we've just been dealing with in Australia in the past fire season in southern Australia. So the estimates are that we had a little over 12 million hectares of country burnt, and that is relative to the 903,000 hectares of forest that was burnt in the Amazon last season. So you can see that this is an enormous extent of fire relative to what's been making headlines around the world. Chris Dickman from the University of Sydney estimates that about 1 billion individual animals were lost directly as a consequence of the fire. Now, that doesn't include estimates of the numbers of animals that were lost through starvation or predation after the fire. John Quiggin from the University of Queensland estimated that the past fire season cost the economy about $100 billion. But I think the really important thing here is that this is one fire season. And often we need to look at a series of fires across the landscape and over time that really have the most substantial effects. So just briefly then, before we get into some deeper fire science and forest science, we need to think about some definitions, because these are often deeply confused in the public and also particularly by the media. So fire intensity is the amount of heat that's generated by wildfires. And usually they're measured in obscure units like kilowatts per square metre. That's different to the fire severity, which is the extent of damage to the vegetation, how much the vegetation is burnt back. And one of the critical things that's really important that often gets lost is the notion of what's called the fire regime, which is the sequence of fires in an area. So how many fires we've had, what time of the year they're burnt, what the interval is between fires. So the sequence of fires is absolutely critical, and we'll talk about that some more as we move through the talk. Now, a wildfire is an unplanned major fire, and that's different to a hazard reduction burn, which is planned and usually takes place in the non-wildfire season. And that again is different from a backburn, which is a planned fire, but it's occurring during a wildfire, and it's aimed at trying to suppress a wildfire and to prevent the movement of that fire perhaps towards villages or townships. Now, a blackout burn is when you have green areas within a fire footprint that remain unburnt but are then blacked out in a subsequent fire that's deliberately lit. So blackout burning is actually quite common. And for example, it was applied recently in the major fires in the areas west of Sydney, in the Sydney sandstone area. And finally, we have the final two kinds of fire: regeneration burns. So the logging debris that's left on a forest are subject to a regeneration burn to start the process of regenerating the fires, or regenerating forest after logging. And a cultural burn is a burn that's applied in an Indigenous context to burn country. Now, the important thing is that some of these categories are not independent. And what I mean by that is, sadly, there are times when a hazard reduction burn can turn into a wildfire. And that has happened quite a number of times in an Australian context. For example, in Western Australia, where parts of Margaret River were extensively burnt after a hazard reduction burn got out of control. So fire is a critical process in Australia, and it's a major ecological process in almost all Australia's terrestrial ecosystems. But when the fire regimes are altered, so remember, a fire regime is a sequence of fires in an ecosystem. Now, when the regime is altered, it can rapidly become what we call a key threatening process. And for example, for birds, only land clearing affects more species, than altered fire regimes. So it's a significant issue in biodiversity conservation in Australia. So the management of fire is actually quite complex. If you think about issues around the numbers of fires, the intensity of fire, the severity of fire. And so good management needs to be based on evidence. But in fact, fire is, I think, the most complex area of ecology in Australia. And that's because every fire is different. And each species in a community of species responds to fire in a very different way. So as we'll see later in the talk, some species remain completely unchanged by what happens in a fire. Other species will be lost for long periods of time. Other species, again, will colonize very quickly after fire. The sequence of fires, that's the fire regime, is very important. And then also we'll see in a moment that the spatial pattern of fire has a really big impact. So how patchy a fire is has a big impact, not only in the forest itself, but also on the species in the forest. The environment before a fire also is critical. So as we'll see again in a few moments, a fire in a very old forest has a very different effect relative to a fire in a young forest. Also, fire interacts with other things. For example, fire interacts with, for example, if a forest has been logged previously. And also fire interacts with the impacts of animals like foxes and cats, but also horses and deer. And so we have a whole plethora of things that make fire really complex and the study of fire really quite challenging. So here's an example of how patchy and different fires can be in different parts of the landscape. So this is outside of Marysville in the Mount Margaret area. And you can see in the foreground, there's parts of the landscape that remain completely unburnt after the 2009 fires. And then in the mid-slope part of the landscape, the area's been burnt, but at relatively low severity compared to the ridge tops where the forest has been burnt at very high severity. And in fact, what's actually been happening there is that area has been subject to post-fire logging or salvage logging. So what's going to happen here is that the ecosystem is going to be quite different in the way that it responds in these different areas. The other complexity in an Australian context is this. This is outside of Marysville, a couple of months after the 2009 fires. And what we see is extensive epicormic growth. And so the trees actually haven't been killed. They've lost their crowns. It's changed the hormones inside the trees. And we've seen this massive resprouting process. And so these extraordinary forests are not dead at all. They're actually recovering and recovering quite quickly. So this is dry, mixed species, low elevation forest. Okay, so now I wanted to change to talk briefly about the links between climate and fire. And so all of the fire science clearly recognises that weather and climate are key drivers of fire. Very few fires burn when it's cool and wet. And so why is this important? Well, this is important when we're studying things like house loss, because we need to account for the effects of the fire weather at the time of the fire to understand the impacts of other things. For example, the contribution of hazard reduction burning to reducing property damage. The thing that's really critical here is that the climate is changing and changing very quickly. So our background rates of carbon dioxide should be somewhere around 280 parts per million. That's what they've been in the past 800,000 years. So when I looked at the data record globally a couple of days ago, on June the 18th, we had 416 parts per million. But some people might have heard that as of today, we clicked over to 417 parts per million. That's relative to a year ago where we had 414 parts per million. So the link between the amount of carbon dioxide in the atmosphere and temperature is really quite strong. And in 2019, last year, we had the hottest and driest years on record in Australia. Now the IPCC suggests that we're on the way to 1.5 degrees within a decade. And I suspect that in the medium term, the IPCC's forecasts are going to be a significant underestimate of climate change and increases in temperature. So this is not a model. This is actually a measurement of how much CO2 is in the atmosphere. And it's called a Keeling curve. And it's measured on a real-time basis in the middle of Hawaii, on the Big Island. And essentially it's a record that started in the late 1950s and has been collected ever since then. Now, the reason why I put the red arrow on this graph was that was the time that I was doing second year plant physiology, where we were doing experiments with plant growth rates in relation to CO2 in the atmosphere. And you can see the extent in just 4 decades, how extensive the change has been in the amount of CO2 in the atmosphere. So this doesn't include other greenhouse gases, such as methane, that have a much higher forcing capability than CO2. So these are real data. People have been collecting this information. Just as this kind of information is collected on temperatures across Australia. You know, one of the most controversial things that the Bureau of Meteorology has done in Australia is to add another colour to the maps for the continent. And that colour is deep purple. And deep purple relates to temperatures above 50 degrees. And we also know that we've seen extensive declines in rainfall, particularly in southeastern Australia and southwestern Australia in the last 25 years. And we also know that there's a very strong link between how a climate is changing and the risk of wildfires. And the latest work suggests that there's a very strong level of link between wildfires and climate change. It's called the science of attribution, where you can attribute particular events to background climate. So 57 scientific studies have been looked at to confirm the relationship between climate change and wildfires. Okay, now I wanted to touch briefly on this notion of hazard reduction burning, because it always comes up after every major fire season that we've had in Australia. Every single fire season that I can remember, dating back to 1983, has always been marked by the comments, usually from shock jocks and others, if only we'd done more hazard reduction burning, none of this would have happened. Well, what does the science of hazard reduction burning actually say? Well, one of the most definitive studies that I've seen has related the conditions associated with fires to house loss. And this was done after the 2009 fires by my colleague, Philip Gibbons from the Fenner School. And what his work shows is that actually it's the quality of hazard reduction burning that makes the biggest difference, not the quantity. And what that means is that hazard reduction burning tends to be most effective in terms of reducing house loss if it's done within a kilometre of that infrastructure, and it's done every few years. So that means that doing hazard reduction burning in very remote areas of Victoria actually have very limited impact on reducing the impacts of fire on house loss. The other thing that's really important is the role of climate. And as I said in the previous slides, the key thing that drives fire is climate and weather. And under extreme conditions, no amount of hazard reduction burning is actually going to limit the damage from wildfires. And Marysville is a very sad case. I was in Marysville in December 2008 when there was a major conference. Excuse me. It was almost impossible to see more than 50 metres in front of your face because of the amount of hazard reduction burning that was being done around the town. And within 8 weeks, the town was absolutely devastated by the 2009 fires. And so hazard reduction is important, but it's important for people to recognise that it doesn't lead to total reduction of risk, especially under extreme conditions. Now, I've been very personally impacted by these kinds of things. This is actually a photograph of my mother-in-law, who lives quite close to Healesville, and they too were caught up in the 2009 fires, as were people that we knew in Steeles Creek. and Marysville and elsewhere. So there's an enormous extent of human tragedy associated with wildfires, and I don't need to be telling people from the Murrindindi region about that. But what we have seen from the mental health research that's been done at the ANU and elsewhere is that these kinds of impacts of wildfires can have effects on people for decades, if not the rest of their lives. What I want to do now for the next 10 or 15 minutes is talk about some forest ecology and its relationships to fire. So the state of a forest before a fire has an enormous impact on what happens during and after fires. So this is one of our long-term sites in the O'Shanassy catchment. We showed this earlier in the talk. And the same site was burnt in 2009. And this is the forest not long after that. So this is a relatively moderate severity fire. The effects of fire are very different when we look at a system that has been logged and regenerated, like this one that we're looking at here. And what we know from the data that we've assembled in the last 3 to 4 decades is that a fire in a very young forest has a very big difference to the effects of fire in an old forest. And this is some of the outcomes of that research. And that is that fires tend to be lower in severity in very old forest. Animals are much more likely to persist when an old forest is burnt as opposed to a young forest. The rate of recovery is much faster, and the rate of recolonisation by animals in old forest is much quicker. There's also compelling evidence to suggest that forests that have been logged and then regenerated are much more likely to experience higher severity fire than old forests. So this graph basically shows the relationship between the age of a forest on one axis and the probability of canopy fire on the other axis. And so a very young forest from age 0 to 7 years old is very unlikely to burn. And then as the forest gets above 7 years old, so in wet forests, wet eucalypt forests, the forest is about 10 metres tall at this stage. The forest has a steep increase in the risk of a crown burn or a canopy fire. And that risk doesn't start to subside until the forest is at least 40 years old, roughly 36 to 40 years old. And then it doesn't return to levels at about 10% probability until the forest is about 80 to 90 years old. So what this means is that young logged and regenerated forests are much more likely to burn at much higher severity. And the thing that's really important here is that this is nothing unusual. This is seen in forests all over the world, and it's been confirmed in some new analysis that's been led by Chris Taylor, but it's also been seen in Tasmania in recent studies that were published just a few weeks ago by a completely independent group from ours. This is people at University of Tasmania. But it's also been seen in the Gondwanik forests in northern New South Wales and southern Queensland by researchers from Macquarie University and more recently, University of Wollongong. So why does this occur? Well, firstly, there's a substantial amount of debris that's left in a logged forest, as you can see from the slide behind us. Now, a large part of that debris is burnt, but there's still a significant amount that remains in the forest. The second thing is that logging substantially dries out the ground in forests. And we know from catchment studies that forests that are logged and regenerated produce far less water than forests that are old. The other thing is that the architecture of the forest is changed. So what happens is that you have a very dense young forest that's growing very quickly. Many of the younger trees are going to lose the race for light and die, and they will add additional fine and medium fuels to the fuel load in the forest. And as I was saying before, the shape of the response curve shows that if we were to log a forest tomorrow, it would still have elevated fire severity risks by 2060. So I would be 100 years old with that elevated fire risk still there. Okay, let's change now to what happens after a fire. The first thing is that a forest isn't completely removed. What we see is what we call biological legacies. So these are the living and dead trees, the shrubs, seeds, whole animals still survive, eggs, those kinds of things. So that's what we call biological legacies. And these legacies are really important because they can promote the persistence of animals on sites, like small mammals. The presence of biological legacies can speed the rate at which a forest recovers after disturbance, and it creates extra complexity of habitat, which is very important. And for animals such as these, the sort of assemblage of arboreal marsupials in the wet forests, the presence of large old trees, which are biological legacies in these forests, is the reason why these animals are still there. Without those biological legacies, 150, 200, 250-year-old trees, these animals simply don't persist in young forests. So a very early successional forest so this is a forest that has lots of biological legacies. It may only take 10 to 20 years for the mammals to start to recolonize those forests. But a young forest without those big old trees, it might be almost 2 centuries before animals can start to recolonize them. And we can see this from this conceptual diagram that's actually built on data that we've been gathering for the last 2 to 3 decades. Okay, so let's look at some other aspects of after the fire. And one of the most controversial areas is post-fire logging or salvage logging. And it's something that we've written extensively on since 2004. And we've done quite a lot of empirical work in the Central Highlands region. And post-fire logging has some substantially negative effects. First of all, most of the large old trees are removed from the system. And so that sets back the process of habitat recruitment for cavity-dependent animals by up to 2 centuries. The composition of the vegetation is radically altered, so we lose many of the fire-sensitive plants, such as tree ferns. The damage to the soil can last up to 80 years, and there are massive impacts on birds, plants, and invertebrates. And in studies in Western North America, post-fire salvage logging actually adds to short and medium-term fire risk. So of all the kinds of logging in forests, salvage logging or post-fire logging is actually the most damaging. So for example, we see salvage logging has the biggest reduction in bird species richness in forests, but it also has major effects on forest soil and forest nutrition and forest composition. So this is work led by Elle Bowd from our group at ANU. And the red boxes basically show different kinds of soil nutrients from ammonium through to sulfur and the like. And it shows the really substantial negative impact of salvage logging in this system. And of course, it makes no sense to be salvage logging areas such as these that are going to naturally regenerate, as we see in this slide from outside Marysville. Okay, so now I think I want to talk about this quite difficult concept of how conditions before and after fires can interact. And this is really important in the context of what's happening in the Central Highlands region. So fire is the main source of natural disturbance in these systems. And the average fire interval should be somewhere between 75 and 150 years in these forests. But what we've seen is 5 major fires in less than a century. And that indicates that something else is happening. And that something else is an extensive human disturbance footprint across these kinds of landscapes. And this is taken from the boundary track outside of Dom Dom Saddle, but we could go to Quartz Creek, Black Range, Rubicon, Royston, Stevenson, Talangi, Powelltown, Penny Saddle, Nuji, Tarongo, and you would see very similar kinds of things. So what you see in this image are all the different logging coops by their age across the ecosystem. And you can see one of ANU's long-term research sites, monitoring sites, that has remained intact through that time. So what we think is now happening in these ecosystems that are burning so often and so extensively is that widespread logging is creating extensive areas of young forest in these wet eucalypt systems. And these young forests have an increased risk of higher severity fire. And repeated fire is burning the young forest, sets it back to continue to being young, to being then susceptible to subsequent reburning. And so the conceptual model for this is this slide here, where a landscape that's largely dominated by old growth has some young forest within it when there are small patches through fire, and then they can grow through to mature forest and keep most of the landscape old, which is largely what we saw before white settlement. What we see in the bottom part of the diagram is a very limited amount of old growth forest, which is exactly what's happening now. 1.16% of the entire mountain ash forest estate is old growth, when it was somewhere between 30 to 60% previously. So this young forest is susceptible to burning, it's salvage logged. Relatively little of the forest then makes its way to become mature forest, which means we have very little old forest. So the cycle of continuous reburning and logging and reburning continues. And we can actually see how the timber release plans from harvesting over the years has actually changed the system and added to the extent of disturbance. And we can see with the timber release plan along the bottom here, just how much of the landscape is being disturbed and how little of the landscape is actually more than 1 kilometre from a disturbance boundary. So we've published this work this year, but also the other thing that's really important is that when we look at the extent of protected areas, we see that the current protected areas are actually not sufficient to maintain viable populations, but also where the timber release plan is slated for areas to be logged, they actually significantly overlap where we have areas of high conservation value for Victoria's 70 forest-dependent threatened species. Now, if people want to follow up any of these things, I'm more than happy to send out reprints of papers that are looking at these things. So this is some of the latest information from the last 20 years of monitoring. And what we see in the first red square in the middle here at the top is that the more of the forest that is logged, the less leadbeater's possums we have in the forest. And that's a highly significant effect of landscape logging. We also see along the top that leadbeater's possum is declining and declining quite significantly, but not as much as the greater glider, which is the one second from the bottom. So what we see, the data are very compelling in these disturbed landscapes. Possums and gliders are declining. In the case of the greater glider, it's declined nearly 80% in 20 years. Logging in the landscape is one of those drivers of decline. We can actually see which things are driving the change. And logging is taking place in the areas with high conservation value for threatened species. And that logging is actually extensively fragmenting the landscape. So if we were to go from an area of intact forest to a disturbance boundary in a reserve in the Central Highlands, that distance is about 1,700 metres. In the wood production areas, that distance is 71 metres. Okay, let's look some more at fire and biodiversity. So sometimes fire directly kills animals, such as this photograph of leadbeater's possum. This is the 2009 fires. But some animals actually persist on sites. So one of our sites at Camberville had radio-collared mountain brushtail possums on the precise time of the 2009 fires. And amazingly, every single one of those individuals persisted. And not only did they survive the fire, but that population remained intact. And you can see the genetic signals in the population from animals that had persisted after the fire. Some animals colonise these burnt areas very quickly, such as the flame robin. And then other species continued to decline long after the fire. Leadbeater's possum is one of those, but the greater glider is really strongly associated with the amount of fire in the landscape, negatively associated. And part of the reason for that is the link between fire and the loss of these very large old trees. So a significant attrition rate of these trees in these burnt systems. So now I wanted to change to some new perspectives on the effects of fire on the timber industry. And this comes from a paper that was published just a couple of weeks ago, where Chris Taylor put together the Victorian government's data sets on the extent of fire, but not only the past fire in 2019-20, but also the past fires that have occurred in the system dating back to 1995. And what we see is that there are substantial parts of East Gippsland in particular that have had 2 or more fires in the last 25 years. So we've published this work, and what we see from that work is that there's a significant increase in the amount of forest that's burning over time. So a megafire is defined as a fire greater than 1 million hectares in size. So there was a megafire in the 1800s, 1851. There was a megafire in the 1900s, 1939. And since 2003, we've had 3 megafires. And the area of forest that's burning is actually increasing quite dramatically. Now, these things have major impacts on resource availability. So everything that Vic Forests, about 60% of everything that Vic Forests had planned to cut in East Gippsland in the next 5 years has been burnt in the past fire season. And that's roughly 30% of everything planned to be logged Victoria-wide in that same time. So in a sort of a quick summary, fire is competing with forestry for timber resources, and fire's winning. And one of the reasons that's happening is that logging is making wood production forests more prone to more fire. And the data actually show that. And we can see that not only in Victoria, but some other work led by other scientists at Griffith University is actually showing that this is the same not only in Victoria, but also in southern New South Wales and northern New South Wales in terms of fire frequency. So the bottom line here is that wood production forests, proportionately by area, are actually burning more frequently than protected areas and national parks. But there's a deeper issue here, and that is that as the climate changes and we see more fires occurring at a faster interval, but those fires should normally be burning every 75 to 150 years, but are actually burning more frequently than that. The normal time that we would see for an optimal rotation time for saw logs should be around 100 years. But there's a very, very low chance of trees actually getting to that age. So there's a 1 in 5 chance. So a 1 in 5 chance the trees will be able to grow through to be 80 years old, and a 14% chance that they'll grow to 100 years old, and less than 5% chance that they'll grow to be 180 years old. So what that means is that most stands of trees are going to be burnt well before they reach an age to produce saw logs. And so this has enormous impacts for the industry. It means that there's a huge uncertainty in the resource, and it means that very few forests are really going to be able to grow through to be harvested. So let's look at the state of the forest in the Central Highlands there. So Leadbeater's possum is in severe decline. The data are compelling about that. Greater glider is declining even faster than Leadbeater's possum. The mountain ash ecosystem is in a lot of trouble. It's critically endangered according to a red listed ecosystem protocol from the IUCN. We've got very little old growth mountain ash and even less old growth alpine ash. There's a very high risk of the forest continuing to reburn. You're going to see lower water yields from younger forests that are using more water to transpire to the atmosphere as they're growing very quickly. We're seeing a rapidly declining timber resource, and a rapid decline in employment in the industry. And in fact, one of the worst kept secrets in the industry is how little resource is left. Now, they're not my words, they're actually words from logging contractors that have told us exactly that. So we wanted to look more deeply at the industry and alternative uses of the forest. And so we've used a system of economic accounting to look at what's happening in the Central Highlands region. And I can provide this information to anybody that wants to follow it up. But essentially what we see is that the areas of this forest are really important for water supply and for tourism and carbon. And there's a significantly greater multiplier for the values of those industries in terms of their GDP contribution relative to the timber industry. The plantation industry itself is in the Central Highlands region is 3 times the value of the native timber industry. And we actually start to see this Victoria-wide. This is VicForest's corporate business plan. And what we see in this is some really important information about the industry itself. And I'll read you briefly. It says, timber harvesting operations in the East Gippsland Forest Management Area have not been profitable for VicForest for many years. Operations currently lose up to 5.5 million per annum after the distribution of corporate overheads. And down on the right bottom part, it says, timber harvesting operations in East Gippsland FMA are not commercial. So when we use economic and environmental accounting, we can actually see how the trade-offs occur in terms of changing GDP if, for example, you were to remove native forest harvesting from this region. And essentially, the state is somewhere around about $100 million better off and potentially significantly more. Other people think that's a conservative estimate and have placed it closer to $190 million or larger. So it's important to point out here, this isn't the end of the timber industry. You need to realise that ABARES data indicates that 87% of all native forest logged in Victoria goes into the pulp stream and the wood chip stream. But Victoria already produces 3.9 million tonnes of hardwood eucalypt pulp logs from plantations. But presently we export almost 3/4 of that, 2.9 million tonnes. So it is possible to process that material in Victoria for Victorian jobs and Victorian manufacturing industries without actually having to harvest from native forests. In fact, 88% of all sawn timber in Victoria already comes from plantations, and it's the same in New South Wales. And over 90% of everybody employed in the forest industry is actually employed in plantations. And the fire science, including that from Tasmania, suggests that plantations are more defendable in the face of fire. So let's conclude with a few things that can be done here. The first thing is, I think it's really important that Victorians think deeply about where you get your best and your highest values from your natural assets. And from native forests, it's clearly water, potentially carbon storage, and it's definitely tourism. The environmental accounting shows that. From plantations, clearly that's where we should be sourcing our wood products, and the carbon research led by Heather Keith suggests that that's the best way to reduce emissions and increase stored carbon in the system. I think it's also important to think hierarchically about this and think about, first of all, fire in relation to the key drivers of climate and weather. Hazard reduction burning is important, there's no doubt about that, but it needs to be done close to houses. And there's also some recommendations from Phil Gibbons and Jeff Carey suggesting that vegetation very close to houses should be removed to reduce the risk of house loss. In a forest management context, I think we need to think very carefully about the risks of salvage logging and the risks of conventional logging. And there is some information to suggest that thinning and wet forests actually has no effect in terms of reducing fire risk. We'll come back to that in a moment. So what do we need to do? Well, clearly greenhouse gas emissions have to be reduced because climate change is a key driver of fire. We need to think about carbon storage as a key industry in native forests. So these are two sides of the same coin. To tackle climate change, we have to reduce emissions, but at the same time, we have to increase the amount of carbon that's stored in the land sector, and native forests are critical to that. We need to think carefully about hazard reduction burning, but also recognise at the same time that it's not the magic bullet, because under extreme conditions, that isn't going to prevent house loss or loss of life. We also need to be really aware of simple solutions. So one of those simple solutions is, if only we'd done more hazard reduction burning. I think that gives people a false sense of risk reduction. I think learning from Indigenous burning is useful, but in some cases, it's not appropriate. For example, the wet eucalypt forests in the Central Highlands and in many kinds of rainforests. Hazard reduction burning, fuel reduction burning is not appropriate. Also, given how much fire we've just seen in Victoria, including in 2019-20, many ecosystems simply should not be burnt anymore. Now, when you've got areas that have been burnt 3 or 4 times in 25 years, that's too much fire. And as I said before, thinning forests generally has limited effects on fire risks, and that paper is presently in re-review. We need to increase the amount of old growth forest in Victorian ecosystems. Some recent work indicates that Victoria has lost 77% of its old growth forest in the last 25 years. I think we need to rethink logging in forests that are become very fire prone, particularly near human settlements. And I'm quite surprised that there hasn't been a class action around that issue, and I suspect that there probably will be fairly soon. I don't think we should be logging burnt areas because of the impacts of salvage logging, and especially high conservation value forests shouldn't be burnt, including when they shouldn't be logged, particularly when they're green spots and become key refuges. I think there's some things we can do around protecting key assets, and we also need to tackle what we call interactions with exotic species, because we know that things like foxes and cats will move up to 12 kilometres after fire to hunt in particular burnt areas. And we have to do the long-term monitoring to really understand what's really happening with fire. So I'm going to leave it there. I know it's been a long talk, and I'm sorry I've talked a lot, but there's a lot of information to cover. And I'm happy to send out material to people if they wanted to follow up with anything that's been discussed. And there's my email address there. And I wanted to thank quite a number of people that have helped immeasurably with this work over a prolonged period of time, but particularly the late Dave Blair and the late Jeff Wood, and also my mother who's recently passed away, who was very dedicated to conservation and forests. So thank you very much, and thanks for listening.
Thank you, David. We might open up the questions now. We've got about 15 minutes, and David will answer as many questions as he can in that time after he's had a little drink.
Yeah, thank you. Sorry about that. Okay, so the next question is, as a secondary science teacher, I'd be interested to know how you think fire science can be included within junior classrooms. I think it's really important to talk about fire as a key part of Australia's landscapes and how we deal with fire, and the learning that's taken place. You know, I think the Victorian government's response to the last major fire season was extraordinary. It was, I think, very well informed by the previous tragedies that have happened, and I think there were lots of lessons for other governments from how Victoria handled what had happened. But I think it's good to be able to indicate to people more broadly from a very young age what all these different terms mean with fire, and how systems can recover and why they recover in the way that they do. So I think there's a lot that can be done in this space, because I think firefighting is going to become an increasing part of Australian psyche. It has to be. And the next question is, what are the issues around the 2019 announcement by the Andrews government re-logging moratorium? Will it come into effect too late? Excuse me. That's a good question. I like to think that, I like to be positive, and I like to think that everything we do as quickly as possible in this space will still make a difference. And it is possible to still recover things, and that includes in forests. I think it's a good announcement. I actually think it's as much an economic and resource announcement as it is a conservation announcement. As I said before, one of the worst kept secrets in the industry in Victoria is how little resource is left. And that means that we actually need to make the transition to plantations and to other industries much more quickly, because we need to provide the social safety net for people to be able to do that, but also transitions like these are much more effective if they're done early. That's the experience from, for example, fishing industries where resources have collapsed, like we're starting to see now in Victoria in forests. Okay, next question is, would you please explain on details about what genetic signalling is within species that return after fire? Okay, so what happened was that one of our team members was an extraordinary scientist called Sam Banks, and Sam worked on populations of small mammals and mountain brushtail possums before and after the 2009 fires. And directly after the 2009 fires, he was able to trap small mammals that were still persisting even in incredibly high intensity, high severity burnt areas. And he took genetic samples, small tissue samples of all the animals that he'd caught. And then he continued to work in those recovering areas and continued to catch animals. And the patterns of genetic variability of the animals that had been caught 5-6 years after the fires showed that they were descendants of the animals that had actually persisted on the site directly after the fire. In the case of the mountain brushtail possum, we had worked in the Campbellville area since 1991, catching mountain brushtail possums and taking genetic samples of those animals, and we were able to see that the survivors after the 2009 fires had offspring that were able to be connected via their genetic variability to the animals that actually persisted directly after the fire. Are there any good resources that we can look at to learn about this? That's a good question. I'm happy to send out materials. I know that the geography teachers have, their curriculum has some resources in this space. My hope would be that as time goes on, we can develop more resources so that the Central Highlands becomes an area for students to come out and learn about these magnificent forests so close to Melbourne. And people in the Yarra Valley can also learn more about the forests in their area. So I think there's an enormous opportunity to develop a set of teaching resources for younger students, but more advanced students, and also other people that want to learn about the forest so close to Melbourne. The question here is, have we been able to quantify the impact of climate change on the recent fires, and how does the modelling work on this? Okay, that's a very good question. So some of the best work that I've seen in this area has been by a researcher called Sophie Lewis, who's now at the University of New South Wales at the ADFA campus in Canberra, and some other researchers, including David Caroli, who's now at CSIRO. So they work on, first of all, the science of attribution, and that's partly based on what we call counterfactuals. So one of the things that we know is that major wildfires are triggered by extensive drought periods of huge rainfall deficits, but also very extreme temperatures. And so what it's possible to do is to work out what we call a counterfactual. So what are the probabilities of extreme temperatures and extremely low rainfall in the presence of climate change versus what would happen if climate change wasn't occurring. And so there's some really good work to suggest that, and strongly suggest, that in the absence of climate change, we would not be seeing these extraordinary series of temperatures, and we wouldn't be seeing the same kinds of rainfall deficits that we're seeing, which in turn underpins the kinds of major fires that we're starting to see. Okay, could hemp in the southern areas of Australia and bamboo in the northern areas replace tree logging for pulp to make paper? That's a good question. In places like Victoria, you already have extensive plantation pulp resources, eucalypt pulp resources, to actually drive the paper industry in the state. So remember that Victoria's native forests are largely used to make wood chips and paper pulp. 87% by volume of everything cut in the state goes into that stream. So it's readily replaceable with plantation eucalypt pulpwood that's presently being exported overseas. And my hope would be to see that that material is actually processed in the state for Victorian jobs and Victorian manufacturing industries as part of the transition for some of these workers. Could we grow these other things in parts of Australia? I think so. There's a need for land assessment, but there's also a need for industry assessment in that space. That's a good question though. Next one is, what do you think of Bruce Pascoe's claims about fire management, specifically ensuring that tree canopies do not touch? So I have read Bruce Pascoe's work. I think the notion of fire management in wet forests and rainforests is not tenable, because those extremely wet forests are not places that naturally and inherently burn on a regular basis. So I think Indigenous burning is really important for lessons in many systems, but I think in these super wet forests and cool temperate rainforests, fire is a rare event that occurs at very high severity, and the notion of low severity, low intensity hazard reduction burning in those kinds of systems with those kinds of climates is not particularly appropriate. And the fact that we had extensive areas of old growth forest and rainforest at the time of white settlement indicates that fires are unlikely to have been applied in a sort of a traditional sense very widely across these systems. The next question is, do habitat hollows get returned to after fires or are generally abandoned by animals? Some animals stay in hollows during fires, and that allows them to survive, particularly in living trees, because the water jacket, the xylem around a living tree that's pumping water from the root systems to the leaves actually is an insulative, provides insulation for animals inside of hollows, same in hollow logs. Do animals return to some of those burnt trees? Yes, they do. The radio tracking work and other work suggests that's the case. There is a huge attrition rate of hollow trees after fires, but at the same time, in some ecosystems, fires actually help scallop out hollows and develop more hollows in the systems, particularly in Western Australia, but elsewhere. The next question is, can really hot fires alter soil structure? Clay fired in a kiln loses physical H2O at around 200 degrees and chemical water at 580 degrees, so it's permanently altered. So there's the same apply to soil. The limited information that we have to date indicates that high intensity fires, high severity fires do have major impacts on soils. It does change the soil structure. Disturbance leads to more sand fraction in the soil composition, and we do lose some significant amounts of some nutrients. If you're interested, I can send you some of the work in that space. The next question is, how is all your information and research being built into forest management and logging practices, and why are politicians making decisions that fly in the face of this research? Okay, so this information and research it's played back, it's fed back to government. The Victorian government does support our research and does support us to keep doing the long-term monitoring, and they have to be commended for that, even when we find things that aren't necessarily palatable. Why are politicians continuing to make decisions that fly in the face of this research? That's because it's a contested space, and the science is competing with heavy vested interests in the union movement, in Australian Paper, the Victorian Association of Forest Industries and others. And what hasn't been done so far is to think through what's the best return, the highest and best return on this public asset. And what also hasn't been done is the basics of a transition plan. That's a good question though. Are there any opportunities to come and volunteer with your group? Most definitely, yes. We've had a volunteer program for nighttime possum watching since 1983. And we have a full-time research officer based in Healesville that coordinates that work. And we'll be continuing to do quite a range of field programs for the next 5 years. And we're always delighted to have people come and help. Waiting for questions.
Wow. Thank you very much, David. Thank you. There are times, you know, when you realise you've heard a really important and compelling message. Thank you so much for your comprehensive, clear and concise presentation tonight and your time in sharing your extensive research. We really appreciate that. Thank you very much.
Thank you. It's a pleasure. And I'm happy to follow up with answering questions by email or sending people out information if they want any further materials.
And with time, the library will have your publications on catalogue.
Thank you. That's great. Thank you, everyone.
Thank you, everybody, for attending. Thank you.